Hi everyone, I am Reusens from Statistics Flanders, and I'm here to talk to you about our project around the use of sentiment analysis on Flemish tweets to create a new official statistic with. We will start the presentation by discussing data science and new data sources for use in official statistics. We'll then talk about how our project fits into this idea and what our goals were with the project. Then we'll discuss the methods followed and the results from those methods. As this research has given us a lot of further research questions, we'll discuss our future work, as well as the work that we're currently still doing around this topic. And we'll end by giving our main conclusions. If you look at the world of official statistics, you will find that almost every statistical office around the world is looking to see how data science and new data sources can be used to create new or improve their existing official statistics. Data science can be defined as follows. This is the definition I pulled from Wikipedia. So data science are methods, processes, algorithms, and systems to extract knowledge and insights from many structural and unstructured data. When thinking of the methods used, we often think of artificial intelligence, machine learning and statistics, and data visualization. New data sources are various and can be sensor data, for example, coming from Internet of Things devices, social media data, coming from Twitter, Facebook, or other social media platforms, satellite images, web data that is, for example, web scraped, etc. So as I touched upon before, national statistical institutes around the world are asking themselves the question, can we use these new data science techniques and new data sources to complement or improve our traditional methods and data? And around this question, several international projects groups have formed, of which I've linked 2 in the slide that I would recommend you to check out. What we're mainly looking into is alleviating several drawbacks of traditional approaches for official statistics, such as the drawbacks of survey data and administrative data. And some of these drawbacks are the frequency, or how often is the statistic generated, the timeliness, how long do we have to wait in between the occurrence of an event and its inclusion in a published statistic, the availability on data on such a topic, might be missing. There could be self-reporting bias in surveys, and surveys also impose a response burden on the respondent. And there are also other drawbacks that these new data sources and techniques could aim to improve. In this project, we experiment with the creation of a new quality of life statistic that comes from the use of machine learning-based sentiment analysis on Flemish tweets. We have several goals with this project. First of all, we see it as a complement or a complementary statistic to our current survey-based perceived subjective well-being statistic. Secondly, we see it as an experience building project, which is our first data science experiment at Statistics Flanders. And it is also our first experiment with the use of Twitter data for the creation of official statistic. We also believe that Twitter data might have other uses. So this is what we're doing. We're starting with a set of Flemish tweets. We're then annotating each tweet as either positive, neutral, or negative, using a sentiment model that is trained with machine learning techniques. For example, the tweet, "I am so happy today," #sunshine, will be labeled as a positive tweet. The news is broadcast at 6 p.m. should likely be labeled as a neutral tweet. and a tweet. Did not win a lottery. Again. Never lucky. Sad smiley face, hashtag unlucky. Would likely be labeled as a negative tweet. Once we've annotated each tweet with a sentiment, we can aggregate those sentiment scores into a statistic that we can track over time and which will show fluctuations in sentiment of the Flemish population. On this slide, you can see an overview of the followed methodology in our experiments. We start with the creation of an experimental dataset using Python and the Python library TweetPy, which makes it really easy to communicate with a Twitter developer API. We only select tweets containing happy or sad smileys to circumvent the need for a labeled dataset. We assume that tweets containing a happy smiley will be tweets of positive sentiment, and tweets containing a sad smiley will be tweets with a negative sentiment. If you would not do this, we would require to manually annotate a set of tweets in order to train our supervised learning machine learning algorithm, which we decided not to do for this experiment, but we will do in the future. A next drawback of our current approach is that we only select Dutch tweets without any geographic limitation. This means that we download tweets from Dutch speakers all over the world, for example, also the Netherlands. We ran this script from Python and TweetPy once, which collected data from a 7-day period, resulting in 19,000 positive tweets and 7,000 negative tweets. From these tweets, we removed the smiley faces, which we queried on, and added a label, positive or negative sentiment. We then followed the basic natural language processing pre-processing steps in order to standardize the text and to reduce the noise. For example, we lowercased all characters, we stamped the word, we created engrams in the text. In order for these texts to be used as input for machine learning algorithms, we have to translate them into feature vectors. To this end, we tried several approaches, ranging from quite simple approaches like word counting or term frequency, inverse document frequency vectors, to more complex approaches like deep learning embeddings. And of those deep learning embeddings, we used both pre-trained sentence embedding models, as well as embedding models that we trained ourselves using our training data. What this looks like for someone who's not familiar with text featureization, the simple featureization could look like as follows, as can be seen on the slide below. The sentence, I like cookies, but I do not like candy, is simply translated to a table in which all word occurrences are counted. For example, the word I occurs twice, the word like occurs twice, cookies occurs once, etc. These vectors can then be fed into our binary classification machine learning algorithms. There exist many of these algorithms, of which we selected what I call the usual suspect algorithms: logistic regression, random forest, gradient boosting trees, and neural network architectures. I am aware that there are many more that we could have tried, but these seem to be the most popular ones, appearing in almost any benchmarking study. So there are several choices in our methodology, ranging from how you do pre-processing, how you featureize your tweets, which classification algorithm we use, and we selected the combinations between these choices, and we did a 5-fold cross-validation evaluation scheme on these different combinations. It was quite surprising to see that the best model that we achieved so far was quite a simple model. Logistic regression in combination with a count factor achieved 81% accuracy on the classification of the Twitter sentiment. We have to say that many other combinations were very close, 80.5% for example, but it was nice to see that you can go quite far with relatively simple algorithms. So this is where we are at the moment. We now know that we can create quite a decent sentiment classification model for Dutch tweets. However, before we start aggregating these tweet sentiments and turning it into a statistic that we publish and offer to our population, we still have quite some questions that we want to answer. The first set of questions that we will tackle in current and future work relates to Twitter as a data source for official statistics. In the statistical community, there's quite some skepticism around this data source, and I believe rightfully so. One of the reasons is that the set of users on Twitter cannot be considered as a representative sample of the Flemish population. It is well known that there are both age and gender biases in a set of Twitter users, and potentially there might be some other biases that we are not yet aware of. Secondly, because we were using the free Twitter Sandbox API, we received what seemed to be a random sample of the available tweets, but we're not quite sure. Nowhere is it described what sample you actually retrieve from Twitter. In order for this data source to have any potential in becoming an official statistic, we need to do further research on these topics. A second strand of future work relates to the machine learning part of this project. We now achieve an 81% accuracy with our best model, but we believe we can do better. For this reason, we're looking at other deep learning architectures, such as the GPT-3 language models. We're also looking into dropping our assumption or our requirement for the tweets that we download to contain a happy or a sad smiley. For us to do that, we're working on manually annotating a set of tweets by a human annotator, and we'll also include the neutral sentiment class, as some tweets clearly don't have any positive or negative sentiment indication. With that, meaning the improvement on our model, you can always ask the question, how good is good enough? That's a question we do not know yet the answer of, but we believe there are still some obvious things we can try to further improve on our machine learning model. We also want to do future research on the comparison between this new experimental statistic and the existing survey-based statistic on the perceived quality of life. It would be interesting to see how these relate and if fluctuations in one statistic can be also found in the other statistic. We are currently working together with a partner that is developing a cloud-based pipeline that will consistently, on an hourly basis, download tweets, annotate them with a machine learning model, and aggregate them into a Flemish statistic. By already producing this statistic, we hope to gain a better understanding on its behavior, and we also believe that by implementing it already, it will form a nice basis for future work. In conclusion, this project has been a great learning experience for us, both in terms of what a data science pipeline or data science project looks like for official statistics, but also as a nice experience with the use of Twitter data. I think we've proven for ourselves that creating a Twitter sentiment model is technically definitely feasible. However, there are still some big questions that remain before we think this type of statistic is official statistics worthy. Good thing is that there's a lot of ideas and things to try to get a better understanding of Twitter data and to better improve our machine learning models. I would like to thank you for your attention. In the chat, my colleague Mark Collins is present to answer any questions you might have. If later in time you still have some more questions or remarks for us, please contact me on the email address linked on the slide. And if you're interested in seeing our Python code used to both download tweets and train our machine learning models, You can do so by looking at the GitHub linked at the bottom of the slide. Thank you.